Now we are creating a new model here using training data set, and you can see there will be a change in our data set. So you can see our split has been reduced. Earlier there were big uh, splits because our data set was a large one. Now our data set is little less large, which you can say because we have only 80% data of our whole set. So now let's go ahead and create a plot out of it. For that I'm using rpart.plot, and you can see our plot has been reduced because it is the 80% of our data that has been used for creating the model here. So I'm just adding features to it. So you can see I have added the node numbers, and the font has been increased using CEX here. Now we are pruning the data set. So if you want to understand first, let's understand this output that we got here. So the total number of observations that we used is 1048, which is the 100% here, out of which we know that majority of the people died. As we can see, it is telling about the at the top of our node, it is saying it that majority people died, out of which 400 survived. So 38% survived and 62% died. Then our first split is based upon the sex of the person. So if they are male, so if it is yes, we go to a node here, that is second node, which says majority people died, but 19%, which means 670, which was the population that was in this node, out of which 128 people survived, which means 19% survived, but majority 81% died when when the person is male. If they are not male, then it gone to a next decision node, wherein it is the third node, which says majority people survived. So if it was female, the person survived, 73% survived, 27% died. The population taken here is 36%. And the next split that happened is based upon P class. So it is passenger class. So if the passenger class was third, the majority of the people survived, and the population taken here is 9%, out of which 93% survived. You can see here it is the seventh. So here seventh node, which says 198 people they died. So sorry, out of 198, 13 died and majority people survived. So 93% survived, and only 0.06% or 7% they died. And if it was not third passenger class, then majority people died. So here you can see the ratio is 50-50%, but still it is saying the people died. So it is the rule that it followed, and there is next split based upon that, wherein because you can see the colors are also changing. Where there is majority, the ratio of survival is higher, it is into dark greenish color. But if it is compared that it is more towards died status, the color is changing to dark blue and telling that it is the status of that node is died. The survival rate of that node is less. So this is how all these splits have been made. So here 2, 12, 52, 53, 27 and 7, these are the terminal nodes. This one is here, so this is the root node. Then these are the decision nodes, wherein the splits have been taken, because there is further splits, as you can see. So these are the decision nodes, and these are the terminal or leaf nodes here. So this is how our tree has been divided when we created our model based upon training data set. Now what we will be doing is we will be pruning our data. So to prune the data, what we will do is, to pruning a tree, we will be taking complexity parameters. So what is complexity parameters? It gives you the complexity parameter, which means how much data and how much complex your data tree will be, then number of splits based upon CP, then there is error rate and cross validation error, then there is standard cross validation standard deviation. So what we will be doing is we will be selecting our complexity parameters wherein the cross validation error is least. So here you can see the least cross validation error is here 0.5650. So for that our parameter is 0.01. So let's take this parameter. So I'm creating a new variable here, dt3b. So dt3 was our last data decision tree that we created. We are taking a part of it, and the function that we are using is prune. First we are giving the dataset name. Okay, so here we are giving the dataset name, so it is dt3. So it is the model that we are using. Then we are saying take the complexity parameter as 0.01, as there is least errors and the splits will be 5. So here you can see in the graph there is 1 2 3 4 5. It is the same data decision tree that we created. There will be no change if you can see. So you can see it is the same data set, because it has given us initially it has already given us the best data decision tree that can be created. Now what we will do is we will take a random CP here. So you can see the next error was least error was 5725, wherein there is only one split, and the CP was 0.017, but here I am taking 0.18. So it is approx that. Let's execute it and let's check our decision tree. So you can see how much our data frame decision tree has been reduced. So but what happens is, if there should be at least 2 to 3 levels to your decision tree, so that you can create a good prediction, you can get a good prediction out of it. You can just what in this after taking 1.8 here, 0.18 here, what happened is our all the splits have been removed, and only the root node has been splitted based upon the sex here. Only one parameter. Although we were having multiple parameters with us, multiple variables, so we could have taken different parameters or variables that were essential for our model. So you should always take that complexity parameter that gives you least errors. So we will be going ahead with this 0.01 variable here that we pruned, this one. So this was a decision tree that gave us a correct or least errors in our model. Now we will be predicting our data. So the data frame, the variable I'm creating here is spread1. The function that I'm using is predict, then giving the model name, giving the new test and new data. So we will be using test set here for our prediction. Then the type is class. So what it happen? It helps us to get a output in the form of qualitative form. Let's execute it. So you can see the observations here. Here it tells you that this died, the person died here or survived. If you take type as probability, it will give you the probability of death and survival. So you can see 81% died, 18% survived. So this is how prediction is given. Now how the 267 is the row number that has been taken in random here. So the second record of our data frame, let's check this data frame first. Our data frame was test. So you can see it was the second record, wherein the it was a male person. The age is very less, it is 0.91. One sibling was and parents too, and it belonged to first passenger class. So what we predicted was, so our prediction says there is 81% chance that this person died and 18% chances that it survived. Similarly, if you would have taken it in qualitative form when the type was class, it says it clearly mentioned that this passenger died. So this is how prediction is taken.